In this segment, we're going to talk about an online system called Write with Transformer, and we're going to introduce the idea of neural network language models. So now that you've seen how bigram language models work, we're going to talk about a more sophisticated version of these that is what get used currently at companies like Google. So I'm not going to talk in detail about what neural networks are. Instead, I'm just going to give you a general idea of how they work. A neural network is a function that maps from the context to a prediction or a distribution over possible next words. This is exactly the same type of thing that we've seen with n-gram language models, but the nature of this function is very different. So in neural networks, this function is very, very complicated. So if you've taken algebra, you've probably seen things like f of x equals 2x plus 3. So we're going to define two things. We're going to say that this function takes one input, which is x. Basically, it takes this x as input and it can return a value. If you tell it x equals 4, it'll return the value 11. And we're going to say this function has two parameters, the 2 and the 3. Because these kind of control what that function actually does with its inputs. So a neural network is going to be a function that has a very particular structure that we're not going to talk about, but it's very, very big. It's going to take over 1,000 inputs, and the number of parameters it's going to have inside it is at least 1 million. And some of the biggest language models in use today actually have 1 trillion parameters. So it's very, very large. We can't write these down easily on a slide. Instead, I'm going to show you a bit of a picture of what they look like. And the thing that makes this all work, and which has powered so many of the advances in AI over the last 10 years, is that you can take derivatives of these functions using techniques from calculus, and that's going to allow you to learn these parameters from data. And so they're going to be able to reproduce what humans do if we have enough data about how humans make certain decisions. Okay, so how do these work for language modeling? So we have a context like the capital of Nebraska is blank. We're going to return to this example. We take each of these words and map it into a 1,000 dimensional vector. What that means is each of these little green bars here is a list of 1,000 numbers. And we have 5 of these here, so we've got 5,000 inputs to the model. Like this is just a big list of 5,000 numbers. All right, now we have a particular layer in this neural network that is going to essentially capture interactions between these different words. This is going to have a lot of parameters in it. It's going to model a very complex function of these inputs. And then we're going to repeat this process somewhere between about 12 and maybe 50 times. And then at the very end, we are going to take this green bar that corresponds to the word is, and we are going to use that to predict the next word. This is going to give us exactly the same output that we saw for n-gram language models. It's going to be a distribution. It's going to say, okay, Omaha has probability 0.9. Maybe Lincoln has probability 0.1. That's not the capital of Nebraska, but maybe it's something that people say next sometimes. So the idea is that this model is supposed to do a much better job than the n-gram model at actually making the right predictions here. All right, so this model is called a transformer. And I talked about this layer that captures these interactions between words, and that uses a mechanism called self-attention. The idea is that each word is attending to or looking at the other words and modeling something about how these words interact. All right, that's a little abstract, but this gives you an idea of how big and how complicated these systems can be. And it turns out that this size and complexity is going to let us build really, really good language models. Okay, so we're going to get to play around with these, and there's a web demo. So we've given you a URL separately that you can navigate to find this Write with Transformer demo. So the first thing I want you to do is at the bottom left of the page, there should be a slider that lets you pick a model size. And the model I want you to use is the GPT-2/medium model. This one's a little bit bigger than the basic one they start you off with. It has more parameters and more layers, so it's going to do a better job of predicting the next word. So then there's this big text area. It looks like a Google Doc. So take that text area, just delete everything there. And then you should be able to see that if you press Tab, any prefix, any context that you have, the model will then make a prediction about what words might come next. So here's what happened when I hit Tab with an empty document. It said a or the would both be reasonable words to start off with. Okay, that makes sense. All right, here's what I want you to do. First, just play around with this. Write some different sentences. Start completing in the middle of them. See what happens. Second, I want you to see what happens when you put in specific entities. Now, entities are basically proper nouns. So maybe write a sentence about a city or a country or a celebrity or something like that. And then see if you complete the model, does it seem to know something about that city or that country or that celebrity? Are the completions kind of generic, or are they maybe specific to that particular thing? See what happens there. And then finally, the biggest difference in these models compared to n-grams is that n-gram models only looked at the previous n-1 words. So in your bigram model, it just looked at one word before. And so you can see how much this might be the case for the transformer model as well. So here's just an example I came up with. At the X, I really wanted to blank. Try some different places, at the ice rink, at the airport, whatever. And see how much that choice of X actually affects things. Now, it wouldn't have affected your 2-gram model or even a 5-gram model at all. But let's see whether it has an impact on what the transformer does. Okay, so here's 3 things that you should play around with. You can also just feel free to have fun with the tool. I think it's pretty cool to see what it can do. So give it a go, and then we'll talk about what I did with each of these 3 things. That's the end of the segment.